Hello, this is Dr. G. Sarat Raju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal. So, today I am going to discuss about streamline, pathline, stream tube, streamlines. So, in previous class we have seen what are the different types of flows, what is fluid kinematics, and how this description of the flow according to Lagrangian and Eulerian description and Lagrangian principle. So in this session, I am going to tell about what is streamline, pathline, stream tube, streamline come across fluid mechanics in fluid kinematics. So the outcome of this module 2 is, at the end of the course, students should be able to apply the fundamental laws of conservation to analyze various fluid flow phenomena and flow patterns, considering appropriate parametric assumptions and limitations. So first we will see what is a streamline. So generally in the fluid mechanics, majority of the times we will talk about streamlines. So the fluid is flowing in the form of a streamline. So when the fluid is flowing over the aeroplane, when the fluid is flowing like air is flowing over the running automobile, especially in case of cars and trucks, how this streamline can be defined. So streamlines are the family of curves that are instantaneously tangent to the velocity vector of the flow. So streamline is an imaginary line in the fluid flow, and if you take any point on the streamline, suppose if it is the streamline, take any point on the streamline and draw a tangent on the streamline at particular point, that is tangent. So the tangent gives you the direction of velocity. So streamlines are a family of curves that are instantaneously tangent to the velocity vector of the flow. So that is why in the diagram shown, there are number of streamlines here we have taken. These blue color arrows are the tangents drawn at different points. Those gives the velocity of the fluid particles in the fluid flow. So these show the direction in which mass less fluid element will travel at any point in time. So example is, we will have some smoke lines in still air showing airflow over an aircraft wing. So if you observe over the aircraft wing at a particular instant, if you release some smoke lines, it can be drawn or it can be shown as a streamline. So that is why when smoke lines in still air showing airflow over an aircraft wing is an example for streamline. So here also we can observe. So the photos taken from the NASA, right? So here how this streamline can be defined. If it is a aerofoil structure, if you observe the aerofoil structure, right? Any aerofoil structure, when the air is blown over the aerofoil structure, here these are in the form of a streamlines. So these streamlines are moving with the object flow goes from left to right. So from left to right, then the flow is steady and two-dimensional flow. So suppose if you take some cylindrical object like this, cylindrical object in the figure shown, streamline is the path traced out by a massless particle moving with the flow, right? Moving the flow. And velocity is the tangent to the streamline at every point. You can take any point on the streamline at any different points. Those lines we can call it as a streamline. And at any point on the streamline, if you draw the tangent, that will gives you a velocity at that particular instant. So that is why velocity is tangent to the streamline at every point. Then mass does not cross streamlines. Then what is path lines? What is path line? Path lines are the trajectories that individual fluid particles follow. So how this individual fluid particles? So in the diagram here, if you take one particle here, the path traced by the individual particle, so it is, suppose if it is taken somewhere here, this point may be traveling in this path like this. So the second position it may come like this, it may come like this. So path line is the trajectory that individual fluid particle follow, or this can be thought of as recording the path of a fluid element in flow over a certain period. Suppose if it is first time t seconds, it is there. After few seconds, it may reach somewhere here. So that is why the path traced by the individual fluid element is the path line. So the path traced by the fluid particle in a certain period is known as path line. The direction the path line takes will be determined by streamlines of the fluid at each moment in time. So what is the practical example? Tracking of color red dye particle in water flow. Suppose if the water is flowing in this way. So suppose a color dye is releasing here. So the tracking of the color dye particle, suppose if it is having some red color, it is traveling, and the path traced by this red color dye is a path line. So the same thing will be observed here. A path line is the actual path traveled by an individual fluid particle over some time period. So this blue color one. So initially the first particle will be there, fluid particle. After few seconds it will reach here. After few seconds it will reach here. After few seconds. So this blue color line represents the trajectory of the fluid particle. So fluid particle, a particular fluid particle, that is path line. So another path particle same as the streamline for steady flow. So if for steady flow, the both streamline and path line are same. Path of particle same as streamline for steady flow. That means for steady flow, path line and streamline are the same lines. Why? For steady flow, there is no change of fluid property with respect to the time. So that is why for steady flow, there is no change in the time. So that is why, because we are the path line, we are taking at instant of time, the path traced by the fluid particle at each and instant of time. So that is why at if the flow is said to be steady flow, we can say both path line and streamline are same, right? Then stream tube. So streamline already you have seen. Streamline, the number of streamlines, can we keep it in the form of a tubular form? We can call it as a stream tube. So a stream tube is a tubular region of fluid surrounded by streamlines. So the number of streamlines kept inside a tubular cross section. A bundle of, otherwise we can say, a bundle of streamlines forming a tube-like structure, that is also called as stream tube. No fluid crosses its boundary. Boundary means this one. No fluid cannot be crossed the boundary. The example for stream tube is airflow through a wind tunnel nozzle section. So in the wind tunnel, generally used for testing purpose of aero wing, so aeronautical aeroplane wings and other parts of the aeroplane, and we can test for the different test airflow over inside the wind tunnel. So that is why the airflow through wind tunnel nozzle section is an example for steam tube. So steam tube consists of a bundle of streamlines. Streamlines at everywhere parallel to the local velocity. Fluid cannot cross the streamline. Fluid cannot cross the boundary. Both streamlines and steam tubes are instantaneous quantities defined at a particular instant in time according to the velocity field at that instant. So steam tube is, if you keep number of streamlines inside a tubular cross section or inside any tube, you can say in the form of a tube, you can keep streamlines, and the fluid cannot cross the boundary. Then streak lines. Streak lines are the loci points of all the fluid particles that have passed continuously through a particular spatial point in the past. So you can observe here, this is the line joining of different color balls or round shaped circles, yellow and red and white. This is a streak line. Streak line. So different fluid particles at a particular instant of time, say time at t equal to 5 seconds. Initially, different fluid particles at t equal to 4 seconds and t equal to 8 seconds. Like that, if at any constant, at any point of time, at a particular time, what will be the, at time t seconds, what will be the path traced by the fluid particles. So that is why streak lines are loci of points of all fluid particles that have passed continuously through a particular spatial point, that is at a particular time. Dye steadily injected into the fluid at a fixed point extends along a streak line. So streak line concentrates on fluid particles that have gone through a fixed station point. So what we have shown in the diagram. So this is the fixed station point. So streak line concentrated on fluid particles that have gone through a fixed station or a point at some instant of time The position of all these particles are marked in a line drawn through them. So at a particular, different fluid particles at a particular time, if you notice how these different fluid particles from a same station or same point will travel. So that is streak line. So streak line concentrates on fluid particles that have gone through a fixed station point or station or a point. At some instant of time, particular say 5 seconds, 8 seconds, at particular instant of time, the position of all these particles are marked and a line is drawn through them. That line is known as streak line. Example is continuous injection of dye at a fixed point shows a streak line. So here continuously we are injecting the dye at fixed point. Streak lines cannot intersect themselves or other streak lines because two particles cannot be present at the same location at the same instant of time. So suppose if you are taking two different points or different fluid particles, they are not existing at the same time at, at, at the same position. So that is why streak lines cannot intersect themselves or other streak lines because two particles cannot be present at the same location at same instant of time unless the origin point of one streak lines also belongs to the streak line of the other origin point. Whenever the original origin point of the same point will be the other point will also same, then only we can have same streak line.
Like, share and subscribe. Hit the bell icon for more updates.